Hey guys, it's Cassie here with OMG Math. If you're struggling with math, don't wait. Click on that subscribe button. If you like what you see today, make sure to comment, like, subscribe, and share. Thanks for watching. Today we're going to practice using sum and difference trig identities to reduce expressions using OMG Math. Today we're going to practice using sum and difference trig identities to do proofs. The first one we're going to do is with sine, and we're going to be using OMG Math to walk through the problem. Okay, so the question that we're given first is prove the following. So we're supposed to prove that sine of x plus pi equals negative sine x. The first thing to observe when doing this problem, on the left side we're given an expression that looks like sum of sine. Our mission is to take the left side of this problem and make it look like negative sine x. How we're going to do that is pretty simple. We're going to take sine x plus pi and we're going to plug it in to its identity and try and get that to reduce to negative sine x. So the first thing we do is we look at this problem. We identify what u and v are. So u is x and v is pi. Then we figure out what the sign is going to be when we expand it. So if this is a plus for sine, the signs stay the same. So it's going to be plus when we expand it. So I put a plus sign here so that I don't forget that this is the operation. Then I plug it into the formula. So I get sine of x cosine pi plus cosine x sine of pi. And then I'm going to go through and start reducing this. Sine of x cannot be substituted, so it stays sine of x. If we look back to our unit circle, at pi, our x value is -1 and our y value is 0. So cosine of pi, our x value, is going to be -1. Plus, cosine of x again does not change. And then sine of pi is 0, so we're going to plug in 0. Now right here, cosine of x times 0, that's going to cancel out because anything times 0 cancels. And then sine of x times -1 becomes negative sine x. So very simply, I have just proved that this equals this. The next proof we're going to do is with tangent. So we're given this formula and we're asked to prove that it's true. This is already one of the formulas we have that we know. We're asked to show why it's true using our sum and difference identities. So the first thing I notice on this one is that I'm given the tangent difference identity. My mission is the same as the last problem. I'm going to prove that the difference identity of tangent, this right here, simplifies to negative cotangent. My game plan is to convert the left side into its identity and then simplify it until it reduces to negative cotangent theta. The tangent formula, there is a formula that actually has tangents. You simplify this mess over here and it has tangents in it, but it doesn't work all the time, so it's not super useful in practical application. Not that any of this is super practical, but it's better to just use this formula so you only have to remember 2 of them instead of 3, especially since the third you can't count on all the time. So we're going to use those to solve this problem. So we take tangent theta minus 3 pi halves and we write it as sine theta minus 3 pi halves over cosine theta minus 3 pi halves. The parenthesis stays exactly the same when you rewrite it this way, just so you know none of the values or anything change. And then we're going to expand it. So on the top we're going to expand with sine. If it's subtraction, remember for sine, the signs stay the same, so we know we're going to be subtracting. Don't be tempted to take the sign of negative 3 pi halves with you. You just take the value. So you take your u value, which is theta, and your v value, which is 3 pi halves. Do not treat it like a negative. And then we start expanding it. So it's going to be sine of theta, cosine of 3 pi halves, minus cosine of theta, sine of 3 pi halves, all over cosine theta, cosine 3 pi halves. And then for cosine, if it's subtraction, we do the opposite. So plus sine theta, sine 3 pi halves. And then again, referencing our unit circle, 3 pi halves is down here, 3 pi halves. When you're at this point, your x value is 0 and your y value is -1, so that's sine and cosine. Cosine's your x value and sine's your y value. So sine of theta does not change. Cosine of 3 pi halves is 0. Cosine theta does not change. Sine of 3 pi halves is -1. All over cosine theta, we know that cosine 3 pi halves again is 0, plus sine theta. Sine of 3 pi halves again is -1. So the nice thing is a lot of things are going to cancel. Sine of theta times 0 is 0, so that goes away. Cosine of theta times 0 is 0, so that goes away. Then I'm left with this right here. So I have negative, which becomes positive cosine of theta, over positive times a negative is negative sine theta. And we know that cosine over sine is cotangent. And since this bottom is negative, a positive divided by negative is a negative. So again, we've proved that this formula also works. So we are done with using our sum and difference identities to prove reduction formulas. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.